If you are a nerdy person like me who asks your girlfriend to send notes, and if there were no such thing called end-to-end encryption, the team at Facebook will be laughing at all your chats. If it is just some notes that other people see, it's okay, we are fine with that. But if we share something more confidential via WhatsApp or even using our Elon Musk X app, that's where things get interesting. Take a scenario where your girlfriend sees a nice dress and asks you to buy it, but you are far from her. You send your credit card details via message, and there is this person who tried to capture all your messages and see your messages. The next thing that you will see is a huge credit card bill. We even share various details like our bank account number. We even sometimes share some of our private photos in WhatsApp. I do that all the time. You almost share everything in apps like WhatsApp. If a person who is sitting in the middle, maybe he tries to change the message and send something goes. Oh boy, you can't even imagine what will happen next. Thank God we at least have this end-to-end encryption. But it will be a total joke when other things come, which I will just say later. End-to-end encryption makes our communication and conversation much safer. When end-to-end encryption is used, a message only appears in a decrypted form for the person who is sending the message and the person who is receiving the message. The sender is one end of the conversation and the receiver is the other end of the conversation, hence the term end-to-end. End-to-end encryption is almost similar to sending a letter that goes through the mail in a sealed envelope. The person sending the letter can read it and the person who is going to receive it can also read it. But the postal service company cannot simply read that because it remains sealed in the envelope. If you are a web developer or if you know some basic networking concepts, there is this protocol called TLS, or you can just think of it like this. A message is encrypted as it travels from the sender to the server of the service and from the server to the receiver. But when it reaches the server, it is decrypted briefly before being re-encrypted. This is the same scenario where a postal service that, upon receiving someone's letter for delivery, opens the envelope and transfers the letter into a new envelope before delivering it to the receiver. The content of the letter could be exposed to the postal service employees during the process. The service might say it won't read your messages when it is not encrypted, similar to how postal service might promise that its workers won't peek at your letters while changing the envelopes, but in the end, you really have to trust that the service will keep its word. And bro, trust is just another word in English dictionary right now. Do not trust anyone. If you use end-to-end encryption, nobody in between can decrypt your message. Users don't need to trust the service they are using as they don't even know what you are sending, and honestly they don't even care about you unless you are an influencer or a top G person. It is really like you are sending a letter in a locked box where you and the receiver has the key. No one else can read the letter except the person that you are sending to. That's how end-to-end encryption ensures that your messages stay private. The encryption modifies the data so only someone with a special piece of information called the key can understand it. Imagine you send a message to your girlfriend, but her best friend intercepts it. If you have an encrypted message with a key that both you and your girlfriend share, her best friend cannot read the message, keeping your message safe. If the message successfully reaches your girlfriend, she can use the key to decrypt the message and read the message. This may seem straightforward in theory, but in practice, there is a lot of thing that is going behind the scenes. The security of end-to-end encryption is determined by the complexity and the strength of the encryption algorithm that is being used. To keep it simple, let's just say there is a private key and a public key generated by an algorithm by doing various complex mathematical computations. In each app that you use which has end-to-end encryption enabled, every account has these two keys. One is the public key, and as the name suggests, it can be a public, anyone can see it. And another one is the private key, which is private to you and no one else should know it. Although these keys are mathematically related, it is really impossible to deduce someone's private key from their public key. But bro, just hear me out. If quantum computers just become mainstream, they could potentially crack these encryptions in just a second. Let's not worry about that because it will eventually come and everything will change. When two people start a conversation, they exchange their public keys. Since public keys do not need to be kept in secret, they can be exchanged over any type of communication channel. When a user wishes to send a message, it is secured using both symmetric and asymmetric encryption methods. In asymmetric encryption, the public key is used for encryption and the private key is used for the decryption. On the other hand, symmetric encryption involves a single session key for both encryption and decryption. In end-to-end encryption, the sender creates a unique session key and uses it to encrypt the data, and then they encrypt the session key itself with the receiver's public key. The encrypted message and the session keys are transmitted over the internet. The encryption makes sure that only the sender and receiver can read the data even if someone interrupts it during the transmission. When an encrypted message is received, the receiver uses their private key to unlock their session key, which they then use to decrypt the message. Imagine you and your girlfriend want to update the key that you are using to make the chat private. Should you share the keys? No, you should not share your keys, because if someone else gets this message while it's on the way to your girlfriend, he could actually sneak into it and read all the future chats. Your girlfriend holds onto a private key and sends the public key to you. This way, even if an outsider snatches the public key, it is really useful, because if you don't have the private key, public key is just a piece of crap. You might be thinking that if you have your private key and your girlfriend has her private key, how can she read your message if she doesn't have your private key? Sounds confusing, right? If this confuses you, you are actually on the right track understanding this. Your message is encrypted using your girlfriend's public key, and on her end, she uses her private key to decrypt the message that you send using her public key itself. If you still think your data is completely safe, hold on a second. Congratulations, you are a certified fool now. End-to-end encryption does keep the message secure while they are being sent to one person to another person. But remember, it doesn't protect the message once they arrive at their destination. On the destination, the message is just simply the message that you sent. Someone can just simply use their big eyes to sneak a peek at your chat and see what you are actually doing. Or if you downloaded an extra 5 GB RAM for free from the internet, you might have already compromised all your privacy, bro. And all these companies like WhatsApp also create a small backdoor, especially if you are a terrorist or a criminal, so that the central agencies can really track you down. But yeah, if somehow someone discovers this backdoor, things are really doomed, bro. And if you still believe everything you do is private, you already lost the game, bro. Privacy is just a myth. You are just a piece of data to a marketer. What you type will be tracked, and eventually you will be an open book. Good luck and welcome to the future.